This is the review packet for 2.1 to 2.3. So in 2.1, we're looking at the distributive property. Got a number outside of parentheses. We're going to distribute it in through multiplication. So very simple on the first one. Both of these terms on the inside of parentheses are going to get multiplied by the -2, create new two terms. And because we have an x and we have no x on the other term that's going to be created, they're not going to be combined. They're going to stay separate as just one expression. So -2 times 3x is -6x. -2 times 1 is -2. And we're going to write that as -2. And that's your final answer. Okay, this has an x. This does not. Cannot be combined. It is not incorrect. So it's okay if you write plus -2. If you brought that plus down and then you do -2 times 1, you get -2. These say the same thing. Adding -2 and subtracting 2 say the same thing. We are trying to simplify completely. And if you're just going to look at these two, which one's simpler? Just the minus. So I prefer, and what you're going to see on the answer keys is the -2 when you get a negative answer, not plus -2. But I do want you to know that this is not incorrect. This is perfectly fine. Okay, on number 2, we're just going to multiply in the decimal. When you multiply 0.3 times 5, well, we know 3 times 5 is 15. We've got that decimal moved over one spot from where it would be if this was a 3, so it's a 0.3. So it's still the 15 in terms of the digits that we're using, but it's 1.5. And the h tags along. And then 3 times 2 we know is 6, it's positive. But it's not 3, it's 0.3, so the answer here is 0.6. Number 2, 3 terms inside, but they're all different. They're not like terms. An r squared and an r cannot be combined. They have to have the same power. So these are going to just create 3 new terms. They're going to stay separate. So just multiplying coefficients here. 2 times 3, 6r squared. 2 times a -1 is a -2r, and 2 times 2 is a +4. Okay, multiplying in here. 4n times 9 is just 36n. The n's going to tag along. But now we have an n times an n. We've talked about that as n squared. What you're actually doing is adding the exponents. This is an n to the first and an n to the first. So when you multiply an n times an n, you add the 1 and the 1, and we get 2, so squared. Number 8. Multiplying by a fraction. Okay, let's first talk about how we do that in a calculator. And let's say you're borrowing one of these graphing calculators. Alpha x brings up your fraction bar, so 2 over 5 times -10. And you're going to get -4. So my first term when I distribute here is -4b. Now let's talk about doing that in our head. Look at these two numbers. They're both divisible by 5. We know 5 goes into them. And this fraction has a denominator of 5. So a shortcut here is to actually divide by the 5 first, and then just multiply by the top. So 10 divided by 5 is 2, times 2 is 4. 25 divided by 5 is 5, times 2 is 10. So I know that this is going to be a 10. The c will be attached. It's a positive times a negative. So we've got a negative answer here, and so it's minus, and this is done. So if you see the numbers are divisible by the denominator, you can divide first, little shortcut, and then just multiply by the top. But of course the calculator works as well. Okay, real straightforward here. Just dealing with the decimal, so -0.6 times 15. That's -9, and that's an L. I'm going to make it a capital L just so it doesn't look like a 1 or anything else. And this is a negative times a negative, so this is going to be a plus. 0.6 times 45 is 27. All right, so this, again, goes back to what we were talking about. If you look at 21 and 14, both divisible by 7. So you would divide by the 7 and multiply by the top. And in this case, since it's a 1 up top, you're going to multiply by 1, but nothing's going to change. So 21 divided by 7 is 3. This is a -3g. This is going to be a negative here. And 14 divided by 7 is 2. Again, times by the top, but it's a 1, so it doesn't change anything. So 2h. So easy fractions to do in your head. That's why they provided those. But let's say, again, you were trying to do this on the calculator. There we go. You hit alpha, the green button, and then the x button right next to it. So alpha x brings it up. And if we were doing 1 over 7, and then we would multiply it by negative 21, and there's your negative 3. So you can do it on the calculator. All right, and then number 12, again, pretty straightforward. We do need to make sure when we do t times t, it's t squared. Multiplying here, you get 120,000 t. That t does need to tag along. Positive times a negative is a minus. And I'm going to get 90. And then t times t is t squared. Okay, down to the bottom, go in the opposite direction eventually. This first one's not, so you're just filling in the blanks here. So if it was 5 times y, it'd be 5y. 5 times z would be 5z. So you're just filling in the blanks. This is y, and this is z. Okay, now go in the opposite direction. Think about if this was distributed, it has to get me this. So a lot of people want to put a 9 here, but 9 times 9 would be 81. So that's what's going to go here, actually. We can put that 9 right there. 9 times 9 gives me the 81, but 9 times what gives me 9q? It's going to be a 1 in terms of the coefficient. We just need the q, and you should always, once you think you've got the answer and run it through, 9 times q gives me 9q. 9 times negative 9 is negative 81. I'm good. Same thing here. 100 times something got me 100y. So it's a 1, but I need the y. And 100 times something got me 300. That's 3. So if you went ahead and distributed this, you should get back to your answer. 2 times something got me 6y. So it's a 3 for the coefficient plus a y. 2 times 3y is 6y. Here's my minus. Now I'm getting a 2 when I multiply. So that means this is a 1, but I do have a y, so I need that y to tag along. Okay, talking about like terms and combining them. So give an example of like terms. So any example. So they're going to have the same coefficient. So something like 3x and 4x. You could also say 3x squared and 5x squared. So even if they have the same variable, they also have to have the same power to be like terms and be able to be combined. You could also just do 3 and 5. If they don't have any variable, they are like terms. They're just whole numbers and they can be combined. So give an example of unlike terms. How about 4 and 3x? So one has a variable, one does not. You cannot combine them. How about 6x squared and 4x? Those are not like terms. They both have an x, but x squared cannot be combined with x. So that's the most important thing to get out of that. Okay, it says use the distributive property to expand and combine like terms. So when we look at this, anything that we would consider a like term can be combined using the coefficients. All of these are x's, so they all can be combined. So when this is all said and done, we're just going to have one term as our answer. It's going to be something x. So we're just combining the coefficients. So negative 3 plus 2, if I just did that piece first, that would be a negative 1x. And then I still have to minus an x. So this is a negative 1 minus 1. That's negative 2x. If you're plugging this in the calculator, you can't put the x in there. But this is just negative 3 plus 2 minus 1. That's a 1x. And you're going to get negative 2, and the x just follows along. Okay, number 4 now. I have two terms using the variable p, and then two terms that are whole numbers. So I'm going to combine my p's and I'm going to combine my whole numbers. Just looking ahead real quick, I see a 3 and a negative 3. When I put those together, that's 0. So they're going to go away. So my final answer is just going to be one term. It's a 2p and a p. Remember, that's really a 1. So 2 plus 1 is 3p. So here we got to distribute first and then combine like terms. You have to distribute first here. Actually, that's not totally true. You could combine like terms on the inside and then multiply. Perfectly acceptable. But when I look at this specific problem, I see four numbers that are divisible by 4. We talked about how to do that with the fraction. You're just dividing. When you multiply by 1/4, you're just dividing by 4. You would multiply by the top, but it's 1, so it's not going to change anything. So I'm going to go ahead and make one quick line here, and then I'll combine like terms. So 16 divided by 4 is 4r. 24 divided by 4, 6. 4 divided by 4 is 1r. And then negative 8 divided by 4 is negative 2. Now I can combine like terms. The r's are going to go together. So that's a 5r. Negative 6, negative 2. It's negative 8, which I write as minus 8, and that's fully simplified. These are not like terms. You cannot combine them. Okay, number 6. I have to distribute before I do anything else here, before I worry about this minus 50. This is a 0.5. It's a half. So when I multiply by a half, I get half of the number. So 0.5 times 4a is 2a. Half of 4 is 2. Half of 102 is 51. Bring down the minus 50. Okay, the only like terms are the 51 and the minus 50, so 2a is going to stay. Nothing's going to happen to that. And 51 minus 50 is positive 1, so I write plus 1. Number 7, before I deal with this plus 6, I need to distribute the 1/7. Again, these are both divisible by 7, so nice and easy. 21 divided by 7, that's 3z. And then 49 divided by 7, 7. Bring down my 6. Looking at this, the 7 and the 6 are like terms. The 3z is not, so I'm going to go ahead and leave the 3z alone. A 6 and a minus 7 is a negative 1, so I write minus 1. Okay, number 9, I'm going to distribute first. So this is 36h plus 18h squared. Bring down the stuff I haven't touched yet. Only combining like terms, so my squareds are going to go together, and my regular h's are going to go together. Now the order that you do this does not matter. You'll notice on the answer key the h's come first, but traditionally in proper form, the highest, if you have the same variable, the highest power is going to come first when you write your number sentence, but obviously the answer key does not do that. They put the 28 first without the h squared. So it's not imperative. It's not going to be marked wrong if you don't do it that way, but I would highly suggest always putting the squared first and then the h, but not a big deal. So when I combine my h squareds, that's 22h squared. When I combine my h's, it's 36 minus 8, so that's 28. It's a positive 28h. Those stay separate, not like terms. H squared and h are different. Okay, I got to multiply here first. So 5 times 4 is 20, but it's not 5 times 4, it's 5 times 0.4, so the decimal moves one spot. So that's just a 2y. 5 times 3 is 15, but it's not 3, it's 0.3, so this is a 1.5. And I have 0.7y. So the y's are going to go together. It's a 7 and a 2, a 0.7 I should say, and a 2. So that's 2.7y minus 1.5. And again, it's fine if you need to use the calculator for any of that. Okay, working backwards again. 7 times something got me 21g, so there's a 3 and a g. 7 times something got me 14, that's a 2, and there's an r. What about if it's a little more complicated? So 3m times something got me 3, so it's a 1. I don't need another number here. 3 times something got me 3. I already have an m, but I got an m squared, which means there's another m here. M times m gets me the m squared, and all of a sudden there's a w, so I need a w right here. Minus is accounted for. 3 times something got me 6. That's 2. The m is there, so I don't need another m. If there was another m, it would be an m squared, but there is that w again. And always double check yourself. If I multiplied here, I would get a 3m squared w. That's what I've got here. If I multiply here, I'd get a negative 6mw. That's what I've got here. Okay, on to the last page where I think we struggle the most. Just in general, from year to year, I see in 2-3. It's just very different than anything you've seen before. Those first two sections, you've definitely studied that in pre-algebra in 7th and 8th grade. So it shouldn't seem brand new, maybe a little more complicated, but you've done it before. This probably feels a little different. So we're going to explain why these number puzzles work by using algebra. So using variables to represent all the steps and seeing what we get at the end. So you're not just plugging in an actual number. We're starting with n to represent a number, and we're going to go ahead and algebraically simplify as we go and see if we always end up with the correct thing at the end of our puzzle. So if we started with n and we add 2, that's n plus 2. Biggest mistake I see there is people want to write 2n. That would be if you multiplied by 2. But if you just have a number and you're adding 2, it's just plus 2. We're not multiplying by 2. We're just adding 2. Now, from step to step, you take whatever you have here and you do whatever it asks you. So when it says multiply by 15, this whole thing is getting multiplied by 15. When I say whole thing, you need to think parentheses. So I'm doing 15 times whatever this is, which is n plus 2, all of it. If you don't put parentheses, you're not multiplying by the whole thing. You're just multiplying by whatever's first. So all of this gets multiplied by 15. So I get 15n plus 30. So distributing the 15 to the n to the 2. Now, this goes to here. I'm subtracting 51. So if I write this whole thing out, 15n plus 30, I'm subtracting 51. And if you want to put this in parentheses, that's fine. But we're not distributing anything because we're not multiplying. We're just combining like terms. So going back to what we just did on the last couple pages, what are the like terms? Well, this n does not have another like term. Neither one of these have n's. So 15n is going to stay the same. 30 minus 51 is negative 21. So this is where students start to get confused because they see multiplication happening to both the n and the 2, and then they see adding and subtracting only happening to the whole number. So we have to follow our like term rules when we're adding and subtracting or combining like terms. Multiplication and division, which we'll get to in a second, happens to all the terms, whether they have an n, an x, or they're just a whole number. Okay, dividing and multiplying happens to everything. So if you can keep those rules straight, it kind of makes this easy. So going this way, we're going to divide by 3, all of it. So 15n minus 21, that whole thing is getting divided by 3. We just worked in the last chapter on splitting this up into 2 pieces. So you could rewrite this if you wanted to. 15n over 3 minus 21 over 3. Each one of those individually will simplify because both 15 and 21 are divisible by 3. You can divide them by 3. So 15 divided by 3 is 5, and the n tags along. 21 divided by 3 is 7. So if you just looked at here to here, you don't have to write all this out. I'm just trying to make sure you understand why we're doing what we're doing. Dividing by 3, the 15's divided by 3, the 21's divided by 3, and there's your answer. Now again, adding, you don't add to both of them. You cannot add 11 to 5n and actually combine it to make one term. It would stay separate. So I'm just adding an 11 like this to the end of this. And so combining like terms, it's only going to combine with the minus 7, so 5n is going to stay. Negative 7 plus 11 is positive 4. And then the last step, subtract 5 times your original number. So we're going back to here. We're subtracting 5 times whatever this number is. So if I'm going to express that algebraically, 5 times n is 5n. That's 5 times the original number. Well, I need to subtract 5 times the original number. So I am subtracting 5n from this. Again, like terms, adding and subtracting, only like terms. So the 4 is going to stay. 5n minus 5n is 0. It goes away. And my final answer here is 4, and that's what we wanted. You always end up with 4, and we've done our algebra simplifying correctly. Okay, number 2. We've got n, we're going to multiply by 5. That's 5n. Subtract 10. You can't actually combine 10 with this and make a new term, so they're going to stay separate. It's 5n minus 10. Adding 5. You can only add and subtract with a like term, so 5n is not going anywhere. Then minus 10 and the plus 5 combine. That's negative 5. We were at minus 5. We're going to divide by 5. All of it gets divided by 5. So the 5 does, that's a 1n, and the 5 does, that's a negative 1. Let's say you wanted to write that out, 5n minus 5. We're dividing it by 5. You can split it into two fractions, or just think about your division like this. 5n divided by 5 is n, negative 5 divided by 5 is negative 1. Add 1, well, it doesn't combine with the n, so the n is going to stay. Minus 1 and a plus 1 is 0, they cancel. I'm left with n, and it says you were always left with your original number. Our original number was n, and so we've done that correctly. Okay, and number 3, we're going to subtract 12. Can't actually do that with an n and a 12, so they stay separate. Multiply by 4, so it's 4 times this whole thing. Multiplication can happen to everything. Both terms take on the 4, so it's 4n minus 48. Adding 12, that cannot happen with the 4n, it stays separate. Negative 48 plus 12, though, is negative 36. Divide by negative 2, both of them, so 4n minus 36, both of them are being divided by negative 2. You can write it as one big fraction or separate fractions. So I'm dividing here. 4 divided by negative 2 is negative 2, and the n tags along. This is a negative divided by a negative, which is a positive 18. And then add 3 times the original number. Original number again was n. 3 times the original number is 3n. So we're adding 3 times the original. We're adding 3n to this. So negative 2n plus 3n. The 18 is going to stay by itself. Negative 2 plus 3 is a positive 1. They don't completely cancel out, so I still have an n, a positive 1n, and a positive 18. So I'm left with n plus 18. It says you will always end up with 18 more than your original number. 18 more than n is n plus 18. Okay, and then your last question is to create a number puzzle that ends with negative 4 times your original number. So we are starting with n. And we're going to create our own number puzzle, but you got to end up with a negative 4n. Negative 4 times your original number. So we got to get from here to here. Now you could do it in one step, right? You could multiply by negative 4 and boom, you're there. But obviously the point of this is to go through a couple steps. So our first step really doesn't matter. We just have to get ourselves here somehow. So when you add and subtract, it's not going to make a big deal at first. But if we do choose to multiply or divide or anything like that, we need to make sure we're kind of staying in the family of 4s or 2s so we can get here. So first thing I'm going to say is just add and then pick any number you want. I'm going to say 5. So we have n plus 5. Now just to be creative, I'm not going to go straight to the negative 4. So I'm going to go to something that I know I can get back to it though. So I'm going to go ahead and multiply. You don't have to do this. Again, there's an infinite number of ways to do this. But I'm going to multiply by 8, because I know if I multiply by 8, I'm going to get an 8n, and I am going to get a plus 40. But I know I can get that 8n to here. All I got to do is divide by negative 2. So next step, I want to get rid of this 40 right now. So I'm going to subtract 40. So when I do that, I'm left with 8n. Now I'm going to go ahead and divide by negative 2. And when I divide by negative 2, I end up at my answer. So this is my puzzle. Take a number, so pick a number. Any number you want. Add 5, multiply by 8, subtract 40, and divide by negative 2, and you will end up with negative 4 times your original number.